Hello and welcome back. Today we shall see the second part of analysis phase, that is requirement structuring. Just to remind you that in the analysis phase is divided into two subphases. One is requirements determination, which we have discussed earlier, and now we shall see the second subphase, that is requirement structuring. Alright, we have discussed about the methods to determine information system requirements, that is requirements determination, and now we shall focus on the widely adopted methods used to present the requirements, and that and there are three basic methods for requirement structuring. The first one is known as process modeling, which consists of data flow diagrams and use case diagrams. Secondly, we have the logical modeling, which includes structured English, decision tables, and decision trees, and the data modeling, which comprises of the entity and relationship diagram, which is also known as the ER diagram. Now we shall see the first method of requirement structuring, that is process modeling, and the very first method is known as data flow diagram. Alright, a data flow diagram is a graphical tool that allows analysts and users to depict the flow of data in an information system. Data flow diagrams is abbreviated as DFD. Alright, DFD graphically represents the functions, process which capture, manipulate, store, and distribute data between a system and its environment, and between components within the system. The final deliverables and outcomes for DFD are: it is a context data flow diagram which defines the boundary of the system. DFDs of current physical system, which is used to determine how to convert the current system into its replacement. Alright, please note down that DFD are divided into two types. We have the physical DFD and logical DFD. Alright, DFDs of current logical system, DFDs of new logical system, and thorough description of each DFD components. We shall see the different components of DFD next. There are only four symbols that represent DFD. That is, we have data flow, data stores, process, and the source or things, which is also known as external entities. A data flow can be best understood as a data in motion, alright, which moves from one place to another in a system. Data store is the storage of data. It also means the data at rest, which may take the form of many different physical representations. The process is the work or actions performed on data so that they are transformed, stored, or distributed. The source or link or the external entity is the origin or destination of data. Alright, we shall see the different symbols and notations of data flow diagrams as proposed by Ginn and Sarson, as well as by Jordan and Coate. Alright, the DFD symbols may vary slightly, however the basic ideas remain the same. There are four basic elements of data flow diagrams. Number 1, processes. Number 2, data stores. Number 3, external entities or the source. And the next we have data flow. Now let us see these different notations. See the notation between Ginn and Sarson and Yuan and Coate. There are certain differences and there are certain similarities as well. Alright. Now let us see what are the physical and logical data flow diagrams. Before actually creating the data flow diagram, you need to determine whether a physical or logical DFD best suits the need. Alright, if you're new to data flow diagrams, don't worry, the distinction is pretty straightforward. Number 1, Logical data flow diagrams focuses on what happens in a particular information flow, such as what information is being transmitted, what entities are receiving that information, what are the general processes which occur in a system. The processes described in logical DFD are business activities. A logical DFD doesn't delve into the technical aspects of a process or system. The non-technical employees should be able to understand these diagrams. Alright, we can say, in other words, logical DFD are a simpler form of data flow diagrams. This is the example. Now, physical data flow diagrams focuses on how things happen in an information flow. These diagrams specify the software, hardware, files, and people involved in information flow. A detailed physical data flow diagram can facilitate the development of the code needed to implement a data system. Or we can say that a physical data flow diagrams depends on the technical aspect, such as the software, the hardware, the files, alright, that are involved for the flowing of information in a system. This is an example of physical data flow diagram. Don't worry, all these have been provided to you in the form of a PDF. Alright, you can study that material, and please also refer to the textbook Modern System Analysis and Design by Jeffrey Hoffer, which has been uploaded by Dr. Hansing. So please refer to that textbook as your core reading material, right? Both physical and logical data flow diagrams can describe the same information flow. In coordination, they provide more detail than either diagram would independently. As you decide which to use, keep in mind that you may need both. Now we shall see what are the different levels of data flow diagram. Data flow diagrams are also categorized by levels, starting with the most basic level, 0, and it gets increased to another level. Alright, DFDs get increasingly complex as the level increases. As you build your own data flow diagram, you will need to decide which level your diagram will be. The first level of DFD is known as level 0 and is known as the context diagram, which is the most basic data flow diagram to provide broad view, which is easily digestible but offers little detail. Alright, it is less detailed and very simple. Level 0 data flow diagram shows a single process nodes and its connection to external entities. Here is the level 0 template of a data flow diagram. Alright. See, it has only a single process or connection with its connection to the external entities. Here the external entities are the guest and the admin. Level 1 DFDs are still a general overview, but they go into more detail than a context diagram. In a level 1 data flow diagram, the single process node from the context diagram is broken down into sub-processes. Alright, from one process, in level 1 DFD, from one process, it is divided into different sub-processes. As these processes are added, the diagram will need additional data flows and data stores to link them together. Alright, you can see here there are multiple storage, multiple processes, and multiple data flows. The arrow here represents data flows. The square or rectangle represents the external entity. Alright. And you can see here the reservation storage, down storage, and up storage, they represent the data store. Level 2 plus DFDs simply break processes down into more detailed sub-processes. In theory, DFDs could go beyond level 3, but they rarely happen. Alright? Level 3 data flow diagrams are detailed enough that it doesn't usually make sense to break them down further. Right? Here's the data flow diagrams of level 2 template. Alright. Now let us see the processes involved to create a data flow diagram. The processes can be broken down into 5 steps. Number 1 is to identify major inputs and outputs in the system. Nearly every process or system begins with input from an external entity and ends with the output of data to another entity or database. Right? Just like here, input from the guest or input from the admin. Alright. Identifying such inputs and outputs gives a macro view of the system. It shows the broadest tasks the system should achieve. The rest of the DFD will be built on these elements, so it is crucial to know them early on. Alright, that is to identify major inputs and outputs in the system. Number 2, build a context diagram. Once you've identified the major inputs and outputs, build a context diagram. Building a context diagram, is simple. Draw a single process node and connect it to the related external entity. This node represents the most general process information on the goes to go from input to output. You will see in the following example. The example below shows how information flow between various entities via an online community. Data flows to and from the external entities representing both input and output, and the center node online community is the general process. Alright, you can see this example. Next, we have the expansion of the context diagram into level 1 DFD. The second, to build a context diagram, that is to build the level 0 DFD, alright, which is the first level of data flow diagrams. Next, we can further expand the level 0 DFD into level 1 DFD. The single process node of your context diagram does not provide much information, so you need to break it down into sub-processes. In your level 1 data flow diagram, you should include several process nodes, major databases, and all external entities. Work through the flow of diagram. Where does the information start and where it needs to happen before each data store. Alright, from the start to the end. Next, we can further expand the level 1 to level 2 or level 2 plus DFD here. This is done in order to enhance the detail of data flow diagram. It follows the same process as in step 3. The processes in your level 1 DFD can be broken down into more specific sub-processes. Once again, ensure that you add any necessary data stores and flows. At this point, you should have a fairly detailed breakdown of your system. Alright, you can see this template again. This is level 2 template. This is level 1 and this is level 0. You can compare each one of these, alright, in order to understand how the simple context diagram of level 0 DFD is being transformed into level 1 and then so on to level 2 or level 2 plus. To progress beyond a level 2 data flow diagram, simply repeat this process. Stop once you've reached a satisfactory level of detail. The last step is to confirm the accuracy of your final diagram. When your diagram is completely drawn, work through it, pay close attention to the flow of information. You can ask yourself whether it makes sense or not, or you can see whether all the necessary data stores are included. By looking at your final diagram, other parties should be able to understand the way your system functions. Before presenting your final diagram, check with co-workers to ensure your diagram is comprehensible. Right? This is an example of the final diagram. Alright, you can check carefully in the material that I have loaded beforehand. Alright, and please, I request you, if you have any doubt, please try to clarify them. Alright. Data flow diagrams should be mechanically correct, but they should also accurately reflect the information system being modeled. To that end, analysts should check DFDs for completeness and consistency and draw them as if the system being modeled were timeless. Complete sets of DFDs should extend to the primitive level where every component reflects certain irreducible properties. Following above guidelines, DFDs can aid the analysis process by analyzing the gaps between the existing procedures and desired procedures and between the current and the new systems. Alright, just to remind you again, the analysis process takes place in each and every phase of system development life cycle. Hence, the analysis phase is also known as the longest phase of system development, because every time you adopt a new process or a new method, it should be analyzed carefully whether it suits the system or not. Alright. Following DFDs, we have another method of process modeling, and that is known as use case modeling. First, let us see what does it mean by use case. A use case is a software and system engineering term that describes how a user uses a system to accomplish a particular goal. Basically, there are three elements in a use case model. First is the actor, then the system, and goals. The use case acts as a software modeling technique that defines the features to be implemented and the resolution of any errors that may be encountered. Use cases are modeled using Unified Modeling Language, or UML. If you see UML, it means Unified Modeling Language. Alright, and are represented by ovals containing the name of the use case. Alright, we shall see all these notations in the following slides. Actors are represented using lines with the name of the actor written below the line. To represent an actor's participation in a system, a line is drawn between the actor and the use case. Boxes around the use case represents the system boundary. Characteristics associated with use cases are organizing functional requirements. Right. Secondly, to model the goals of system user interactions. Number 3, recording the scenarios from trigger events to ultimate goals. 4, describing the basic course of action and exceptional flow of events. And permitting a user to access the functionality of another event. The steps in designing use cases are: identify the users of the system. Alright, firstly you have to identify who are the users of the system. For example, in a university library, the users of the system are the employees, the students, the research scholars, the teachers, etc. For each category of users, create a user profile. Alright, you can divide or you can categorize the users. This includes all roles played by the users relevant to the system. Thirdly, to identify the significant goals associated with each role to support the system's value propositions identifies the significant role. Next, create use cases for every goal associated with a use case template and maintain the same abstraction level throughout the use case. Higher level use case steps are treated as goals for the lower level. We shall see the different levels later, alright, or in the following slides. Next, we can structure the use cases, and lastly, we review and validate the users. Right? A use case is a description of how a person who actually uses that process or system will accomplish a goal. Or simply we can say a use case is that method to determine how a user uses a system. Alright, it's typically associated with software systems but can be used in reference to any process. For example, you are a cook who has a goal of preparing a grilled cheese sandwich. The use case would describe through a series of written steps how you cook or how the cook would go about preparing that sandwiches. The use case helps you to understand where errors could occur in the process and design features to resolve those errors. Alright, the three elements that a use case must contain, I've mentioned this to you also about this earlier, that the use cases involve three elements. Alright, firstly, the actor, which is the user. It can be a single person, a group of people, or an institute interacting with a process. System, which is the process that requires to reach the final outcome. And goal is the successful user outcome. Again, the goal, or in other words, a goal is a successful output. Additional elements that are included in a complex use case are stakeholders, which are those who have an interest in how the system turns out, even if they aren't direct users. Preconditions, which are things that must be true before a use case is run. Triggers, which are the events that occurs for a use case to begin. Now let us see the use case diagram at a glance. A standard form of use case diagram is defined in the Unified Modeling Language as shown in the use case diagram example below. Alright, first we have the actor. It can be represented by a stick diagram. Alright, actor is someone who interacts with the use case or a system function, is named by a noun. Alright, either proper noun or common noun like teacher and so on. Actors plays a role in the business similar to the concept of users, but a user can play different roles. For example, a professor can be the instructor and also researcher and play two roles with two systems. Actor triggers use cases. Actor has a responsibility towards the system. Alright, actors can give inputs and also actors can be rewarded with outputs. Alright. Use case is the system functions or the process which are automated or manual. It is named by verb or noun. Alright, such as it do something. Alright. For example, what does a teacher do? Teaches, right? We teach you. Teaching is a verb. Alright. Each actor must be linked to a use case, while some use cases may not be linked to actors. Communication link, it is represented by a line. The participation of an actor in a use case is shown by connecting an actor to a use case by a solid link, that is, a line. Actors may be connected to use cases by associations, indicating that the actor and the use case communicate with one another using messages. Then we have the system, which is represented by a rectangle, alright, a vertical rectangle. The system boundary is potentially the entire system as defined in the requirements document. For large and complex systems, each module may be the system boundary. For example, for an ERP system of an organization, each of the modules such as personnel, payroll, accounting, etc. can form a system boundary for use cases specific to each of these business functions we can see in the following example. And the entire system can span all of these modules, depicting the overall system boundary. You can refer to this example here. Alright, or on how all of the notations are represented in a use case diagram. You see here the vertical rectangle is a system, and the use cases here are handle message, handle call, and manage bill. Alright, the actor here is a cellular phone customer and the external phone company. And you can see these lines, alright, these are all the association links on how the actor is associated to the use case in a system. Alright, let's move on to the use case levels. Use cases has different levels as well, such similar to DFD, and one method, which is defined by Alistair Cockburn, uses the following altitude metaphors. White, which is the highest level, like clouds, this is the enterprise level, and there may be 4 to 5 for the entire organization. Example of such level or example of use case in this level may be to advertise goods, sell goods to customers, manage inventory, manage the supply chain, and optimize shipping, etc. Guide is lower level than white, but is still a higher level, it providing an overview. The guide use case may be at the business unit or departmental level and is a summary of goals. Such examples would be to register students, or if working with a travel company, it is to make airline, hotel, car, or cruise reservation. We shall see the following example on how these levels are represented in a use case diagram. Blue is the sea level and is usually created for user goals. This often has the greatest interest for users and is easiest for a business to understand. It is usually written for a business activity, and each person should be able to do one blue level activity in anywhere from 2 to 20 minutes. Examples of use case in the blue level are to register a continuing student, add a new customer, or add a new member, place an item in a shopping cart, and order checkout. The indigo or fish is a use case that shows lots of details, often at a functional or sub-functional level. Such examples would be are chosen as a class, to pay academic fees, look up at the airport code for given city, and produce a list of customers after entering a name. The black or the clam, like the bottom of the sea, are the most detailed use cases at a sub-function level. Examples might be to secure lock-in validation, adding a new field using dynamic HTML, or using Ajax to update a web page in a small way. you can see this example here. At the white level, all right, you have the overall project. In the kite level, you have to advertise, order, and invoice. Blue level, we have to set up promotion, reference promotion, monitor promotion, place order, etc. All right. See here. The highest level is known as level 0. All right. Use cases diagram are opposite of DFDs. All right. The level 0 in use cases is considered as the highest level, whereas the fourth level, that is the clam level here, or black, is known as the lowest level. All right. You can refer to this. You can see this diagram here. Cloud level is also known as the white level, kite level. Then we have the sea level, which is blue, fish level, which is also known as indigo level, and the clam level, which is at the bottom of the sea, is known as the black level. Right? Please note that while a use case itself might drill into a lot of detail about every possibility, a use case diagram is often used for a higher level view of the system as blueprints. It is beneficial to write use cases at a coarser level of granularity with less detail when it is not required. The three main areas of use case are the aerial header containing cases, identifiers, and initiators. Number 2, we have the steps performed. And lastly, we have a footer area containing preconditions, assumptions, questions, and other information. Here are the reasons why we write use cases. The first being, use cases effectively communicate system requirements between the diagram because the diagrams are kept simple. Use cases allow people to tell their stories, that is, to give their opinions, views, or inputs. Alright? Use cases stories make sense to non-technical people. Alright? Because use cases diagram are always kept simple in order for everyone to understand the processes involved in a system. Use cases do not depend on a special language. Alright? Use cases describe most functional requirements such as interactions between the actors and applications, such as the interactions between the actor and the software, or the actor and the hardware that I use. Alright. Use cases can describe non-functional requirements such as performance and maintainability through the uses of stereotypes. Use cases help analysts to define boundaries. Alright, we always have a system boundary in a use case. Use cases can be traceable, allowing analysts to identify the links between the use cases and other design and documentation tools. Alright, we can always trace the use cases by allowing the analyst to identify the links between use cases, that between one process and another. Alright, and from one design to another, and then document them, alright, in the form of reports or procedures. Alright, and in the next class we shall see the logical modeling, which comprises of structured English, decision trees, and decision tables. For now, we can stop here, and that is all about process modeling of requirements structuring. Thank you.